All right, thank you very much. Hope everything is working. Trying something out, something new out here. We're going to record this talk, so I hope everything works. But this is the setup for more meetup, so it should hopefully be fine. Good. I want to talk with you guys about Cloud Events. So, who of you has used Cloud Events in their project? One person. All right, awesome. Who has heard about Cloud Events? All right, couple of people. Everybody else, no clue? Yeah, okay, that is fine. Good, short introduction about myself. Hello, my name is Christian. I'm a freelance software engineer and software architect living here in our lovely Stahlstadt in Linz. I'm mostly doing C#.NET stuff, but I'm a freelancer. If you pay me enough, and I mean good enough, I will even do PHP. I like C# that much that I recently started hosting the .NET meetup here in Linz. It's called the .NET Stammtisch. So if you're doing .NET stuff, make sure to visit one of our meetups. It's really nice there. If you want to reach out to me after the talk or whatever, I'm on Blue Sky. I'm also on Mastodon, LinkedIn. Just search for me. I'm sure you will find me. Good. Let's talk about Cloud Events. Cloud Events themselves on their website say a specification for describing event data in a common way. And that might sound somewhat cryptic, but we will get to it down. The main problem is, this is a somewhat usual Cloud Native Linz talk. Who of you is here for Kubernetes stuff at a meetup? Couple of people, yeah? Who is here for the free beer and pizza? Yeah, sure. So there won't be any fancy Kubernetes stuff in this talk, I'm sorry. Also, this isn't something new. There is nothing really groundbreaking in this talk. This is more a call for help or a call for standardization. You might ask why. This is why. Now this is Event Grid, this is Google Cloud Functions and IBM whatsoever and Adobe something. And there are a lot more samples on the Cloud Events website on all the different kind of, well, Cloud event specifications, if you want to call them. So the smart people at the CNCF got together and said, we need to fix this. I'm not sure if it will end up like this. I hope not. I also would argue it's a little bit different because there aren't really 14 standards out there. There are maybe like 10. Also, it's more like proprietary, like we just build something and don't actually think about operability. So I wouldn't argue that there are like 15 competing standards. Now there's one standard and it's called Cloud Events, so you should use it. Good. What are Cloud Events? Cloud Events is a CNCF project since 2018. I think it got started in 2017, was upgraded over the past year to a maturity level and is now a full CNCF project. It provides a course specification on how, in their opinion, cloud events should look like. And they support a variety of ways on how to do that. So they support different kind of formats, for example, JSON, but also different kind of bindings for different kind of protocols like HTTP. We will get to that in a second. And they also provide documented extension specifications for the course specification. So you're not locked into whatever they say you should it like that. You can extend it in any way you want. And it comes with a lot of SDKs for various programming language, different kind of tech stacks. To be more specific, those here, PHP is included. Look at that. I think it has everything you need technology-wise. Maybe I would miss something for C, C++, but we have Rust there. So is anybody missing something? Perl? Okay. Do you still use that? Yeah. Okay. Sorry. Just kidding. Good. So Cloud Events themselves say on their website that they have 3 goals: consistency, accessibility, and portability. And what they basically mean is, like, if we would have one unified standard, everything could be so much easier. Because let's say you want to integrate different kind of the systems I've shown before. They all have different standards on how they interact. So you always need to rewrite the event handling logic for those kind of things. We wouldn't have that, of course, if we would have just one. Accessibility is given with all the SDKs they provide, so it's really easy to integrate. And the same thing with portability. Like if we would have one common standard tooling, we could write one event sourcing system that we could use for all the different kind of services and platforms. So much in theory. Let's look at this magic thing I've been talking about. And it's this. Yes, that is everything. It isn't more. That is on how a cloud event, at least in the JSON format, looks like. And it's very simple, very basic, and that is the idea behind of it. But as mentioned, they don't only support JSON. You can map a cloud event onto an HTTP request in a binary format where they will use the HTTP headers for some of the specification, but you can also use the structured one where you basically just have the full JSON as a body then in the end. And that makes sense if you think about events, because one of the most common event integrators we have at this time are webhooks. And if we would have this, if we can apply the same thing that we use for message broker kind of stuff where we send out event and messages, why shouldn't we be able to apply it to webhooks, which are also kind of event, to just use HTTP as a protocol? And as mentioned, there is a lot of support already there right now. So they support JSON and protobuf from a format point of view, but they basically cover all your favorite messaging protocols like AMQP, Kafka. If you're still using MQTT, please get help. But it's all there, even WebSocket. So that is pretty awesome and pretty cool. Let's talk about the core attributes, the core specification of it. And it is pretty simple. You start with an ID. Each event must have a unique ID. It needs to be a string. Either you're doing an event counter that the producer manages, or you just use random GUID, stuff like that. Just make sure that you have a unique ID. If you're doing stuff like event sourcing, where you're going to replay events later, the ID can stay the same because it's still the same event, you're just replaying it. So that is fine in that case. Source property needs to be some URI reference. That is very nice for debugging things, to know where things originally were coming from. So the specification tells you here to either use an internet-wide URI, an URN, or some application-specific thing like the end of like from the front end, the part after the domain. I don't 100% like this part, because usually if you build a backend API and then a single page application fronted to that, it's kind of easy, kind of hard to get the front end URL into this kind of backend thing. So I don't really agree with like that an absolute URI would be recommended here. Also, this might still work out if you're doing REST APIs, like real REST APIs. But the moment you're using GraphQL, you have one endpoint, and then this basically doesn't work. So that's the point where you would need to divert from what they would recommend from a standard point of view. I can tell you how we did it. We basically used either the deployment names or the pod names of from our services running in our Kubernetes cluster. Fuck, there is Kubernetes. And use that one. That is really nice for debugging, because then you can even see like which pod published it if they are living long enough at least. But mostly I probably would recommend like the deployment. Good, next one, spec version, very easy. Set it to 1.0 because that is the current version of CloudEvents. Then the type is something where you can set type information. You can add versioning there. You don't need to. If you don't need versioning, it's fine, you can skip it. The specification says that you should prefix it with a reverse DNS name, so like you manage packages in Java. We're not really doing that in C#, so I honestly never did it, but that is the recommended way. And you can do the versioning any way you want. I usually went with just like add it at the end because it makes sense. Good, data content type needs to be according to the MIME specification, so application/JSON, for example. And it just defines on how your data payload will look like. We can keep the subject very short because it was recently added. With recently, I mean the past years, but we never used it. So for example, one sample I found online where you could use it, let's say you want to get an event about that a file was uploaded, then a subject could be, for example, the file name of that file. So you get some connection on what actually happened. But yeah, I honestly didn't have any use for this field so far. But it's optional anyway, so you do not need to set it. Next one is time. According to RFC specification, standard timestamp, as you know and love it. And one thing that might be interesting here is that the specification says that the time field should be when the event happened. That might be a date time in the past. Think about migrating data from an old legacy system. So you might have very old date times in there because that's when the event actually occurred. That's when the occurrence of this fact happened. We will talk about that later again. And the last property from the core specification is the data property, which is the event payload. And this can be anything you want. It can be primitive types, it can be complex types, it can be null. Actually, it is optional. So if you have an event where you don't have any event payload, you do not need to specify this one. Obviously, whatever you put into a data property, it should be according to what you specified in the data content type. But if you use the standard SDKs, at least in C#, you do not even need to take care about the data content type because it will get set automatically. Good. As said, there are extensions. And extensions are an awesome thing because basically what we saw so far in the core specification, all that kind of stuff is not like you can only use that, but it's more like these are the reserved keywords, do whatever you want. So you can extend any cloud event in any way you like. So there are no limitations, but there are some extensions that more people needed in the past. So they specified them and put them into their GitHub repository. And we take a look at some of them that are interesting. One that I think you most likely would need during your software development is the auth context. So if you have any kind of authentication information in there that you want to transmit to a consumer, then this is the way to go. It specifies 3 additional properties. One is the type, like you can be an application user, you can be unauthenticated, you can be unknown, whatever. You can just put it in there. Then you might have some kind of user ID that identifies the user. And the last one is also a pretty open one again, it's the auth claims. Auth claims basically just says whatever claims that the principal had. The specification specifically tells you to not put any password, tokens, secrets, API keys whatsoever in there, but you may add any information needed to impersonate the previous user. So the consumer side, with its own service principal and with the permissions on its own service principal, could go to an identity provider, say, hey, I would like to impersonate the user with this ID, and I would like to have these claims attached to it so I can consume the message and process it. From a security point of view, like if you want to build a secure application, I think this is something that you probably want to do. Also, it helps managing some stuff if you have created by, updated by things in your databases and you're automatically updating it based on the user ID in some kind of scoped context, then it's a pretty nice way to just impersonate the user that originally was responsible for creating this fact, for generating this event. The next one, and I think Giuliano will like this one, it's distributed tracing. You should definitely use that one because the moment you're doing events, you're distributed, at least in some way or another way. So you want to have tracing. There are 2 new fields, trace parent, trace state. Trace parent should be filled with W3C trace context, so version dash trace ID dash span ID dash the options. If you want to do tracing over multiple services but keep the tracing separate between the services, you can use trace state. So if you have system A, B, and C, and they're already big and complex and you don't want to do distributed tracing over all 3, you can, for example, send out the event in system A till it arrives in system C, you could have a list there with system A equals this trace ID, system B equals this trace ID. So you still have that information available on the consumer side, so you can attach it to your trace, but to not automatically group it into one very, very big trace, which might be hard to actually view at the end in your observability system. Good, couple of others. Expiry time. There might be events that are only valid for a certain time, like a temperature sensor that publishes its temperature once a minute. So that might be limited to only 1 minute, but of course depends on what kind of system you're building. If you want to record all the temperatures, then you might want to ignore this one. But if you're only interested into a latest one, then this field can help you saving, like processing unnecessary events that are not valid anymore. Good, for all the Kafka fans, there's a partition key, nothing more to add there. And one other thing that I really recommend adding is the recorded time. So we talked about the time field already and that it can be in the past, especially if you migrate data from a previous system. The recorded time is the second timestamp you add, which is about when the occurrence was recorded for this cloud event. And this might be basically now, like when you create this cloud event now. So you basically have both timestamps in there, once when it originally happened and once on what time it was actually generated. That helps a lot for debugging purposes or if you're doing event sourcing and that kind of stuff. These are by far not all the extensions. This is the rest of them. So yeah, pick whatever you need. It's basically like a big Lego modular building set. There's something for data classification if you're doing GDPR stuff. There is for something for deprecation, for sequences, for sampling. Pick whatever you need. Or as said, if you really have the need, you can always create your own extension because it's not limited. If you need an additional property, add it. If you need an additional property for distributed tracing because your system does it in a different way, add it. Doesn't matter. Everything is basically allowed here. Good. Let's talk about who is on board to this thing. As mentioned, it's not something new, so there should be some adoption out there. And there is, in fact. So this is a sample. These are 6 samples from their website. The list is way longer. Check it out on the CloudEvents website. But we have Microsoft with Azure, we got Amazon, we got Google Cloud, we got Adobe, we got SAP. Yeah, even they support it. So there's no reason for you to not use it with your legacy system because they support it too. Take as example Azure Event Grid. So for those of you who do not know it, it's kind of an IoT solution to handle millions and millions of events. You can get those events within a cloud event nowadays. And either as a JSON or even directly as an HTTP request, because with the HTTP protocol binding that we talked about. There are again 2 Kubernetes stuff that you might know, like Argue Events and Captain. They are also using Cloud Events in some way, but I don't have much experience with them. I just put them on there because I have heard about them, and you probably have, so I thought it would be a good sample. Good. Let's talk about the last one. Which is a little bit of a case study, like one of my customer projects where we used this one. So we were building a business-to-business application, quite a big one, quite distributed over multiple different development teams and even multiple different departments. And what we're basically doing at this point, we are synchronizing data asynchronously in a message-based system. So we mostly had kind of business events, like with data that is important, it must not get lost, versus comparison to, like, for example, IoT stuff where you might record data from a sensor and it isn't that kind of a big critical problem if you lose data for an hour because then you don't have the temperature, so what? A little bit different for us. And we used a couple of extensions, so we used the off-context distributed tracing and recorded time. But again, this really depends on what kind of technology you're using, on how your business processes basically look like, and based on that, you can pick all the extensions that you need for your project. So what did we do with it? We specified it as a common messaging format for all kind of events. So we had communication between services, we had communication with serverless stuff even, and all that kind of stuff, everything, which makes it really nice because it reduces the cognitive complexity for your developers, because they're always dealing with the same thing, just like once it's a service, once it might be function or lambda or whatsoever, but it's always the same format. We can always read, and that is pretty neat. Also, we use, as mentioned, we used the distributed tracing extension, and we took that one for the integration into our message-based broker message system to make sure that we had distributed between services or functions or whatever within our engineering department. So not to any other kind of departments. There would have been a lot of on-premise things to integrate, let's call it like that. This would probably, for the little bit more far future, to get those one also on board. But so far, we have used it just in our project in the engineering department. Last but not least, something that we also did back then, because there wasn't really a solution out there, was building our own event sourcing system. I cannot recommend to do that. And also, this would be the benefit now. There would be now an event sourcing system that uses CloudEvents. So theoretically, you could use it for all cloud events. The only problem is it's closed source. So one of the benefits that like we build a system and theoretically now everybody could use it, unfortunately you can't, because I cannot show it. But for us it really helped because the whole system was using CloudEvents. We built one cloud events-based event sourcing system. No events with that in our system. Good. I have a small little demo, not much. So I didn't set up all the message brokers and all that kind of thing because it doesn't really help much for the demo. So basically what I want to show here to you is just a sample on how to use the SDK. So this is C# code, obviously, because I'm the C# guy. I'm gonna guide you through that, but it's pretty simple, pretty easy. We're starting an activity up there, so we get some tracing. And this is my very simple message that doesn't have any meaning or much content. Cloud event here. Specify all the properties you want to specify. As mentioned, I'm simply using the type as a value for the type field. Maybe you want to add a prefix there or format that differently. For us, that was basically fine. Then I'm adding some of the extensions here. So the extensions obviously don't have like this nice support here from a developer experience point of view because they are not part of the core specification, so they cannot be part of K themselves. But basically, you can set any string can set values for any string. I specified this one here in an external class, so it's reusable, and it's just a constant string which says traceparent. That's it. And then the ID which we started up there here. And then this is also coming from the SDK. This is just a JSON event formatter. That's for example, the way on how to format this one now onto a JSON. You can provide all the JSONs you want to have it. So for example, I set the right intended here, so we get a pretty print in the console in a minute. And then you can call this encode structured mode message. There would also be another one, which is called mode message. So that's the difference we saw for the HTTP sample, like if you want to have it part of the headers or if you want to have it part of the body. Good. And the last part is just here for the demo. You would get like a byte array to your message broker. But in my case, I would like to have it as a string so we can print it onto the console. So with UTF-8. And if we start now, it's pretty simple. You can see now we have the full JSON specification, so the full JSON representation of our cloud event. And as you can see, there's the data content that was automatically done because we used the JSON event formatter. And yeah, that's basically it. Good. Let's go back to this one. Recap. Please use CloudEvents. Make your system interoperable between all the different things we're doing. Who of you still does data syncs with CSV files? No. Good. At least you're honest compared to all the other ones, because I don't believe you. No, seriously. I would love to see more interoperable systems. The easiest way to do that nowadays is webhooks, and there's basically much specification or standard for webhooks, except for like it's an HTTP request, usually authentication optional, hopefully an API key somewhere. But if we have a specified standard for all this kind of events, systems could be a lot easier, and that's what I would be really hoping for, because I don't want to build another CSV export or import in my next project. And that's basically it. Couple of links. So CloudEvents website, I already mentioned that one. All of their stuff, all the specification is on GitHub in the CloudEvents organization. They have a repo called spec where all the different specifications are, including the extensions. There are also other repositories for all the different kind of ways from the different programming languages. And that's basically it from my side. Please standardize your stuff. That's my whole message. Any questions? Yes.
Is there a validation for it? So besides being a valid JSON, so that you fulfill the specific.
You mean for creating it or for parsing it?
For receiving the event.
Yeah. So you have the SDK, and it basically makes sure at a lot of points that you can only do the things that are required to, at least from a C# point of view. I can tell you that. So, for example, you cannot create a cloud without specifying ID, because the ID is required. So it makes sure that the stuff that is specified specification, that you have to do those kind of things when you deal with the SDK. Why do I know that? Because at the very with this project I was mentioning, we kind of were not aware that there are SDKs, and we implemented our own ones. And at some point, we migrated to the official SDK and realized we were not according to specification. And so we had to adapt 1-2 things to be according to specification. And yes, the CloudEvent SDK basically screamed into my face, "What the heck are you doing?" Yes. Yes.
As everyone knows. I see some gray area here in what would be a span, or do you have experience on that?
So basically the way we, and I'm not that open telemetry, so I'm not sure if I can answer that 100%. But basically the way we did it, we had like one service A and service B, one produced the message, one consumed the message, or like B and C consumed the message in the end. And basically what we wanted was to see, okay, when I put in a trace, that I can see that we have the producer here, and then within the same big distributed trace, in B and C actually consumed these messages. And that's what we achieved with the distributed tracing extension. So you just start, like, give the last trace from the producer side, and then basically directly continue on the consumer side. And of course, you have a gap in between where you went through the message broker. So we hadn't really set up any specific there besides the you already got from the Open Telemetry SDK for. So we used Azure Service Bus, and there is some ready-to-use SDK to get a little bit of additional traces and information out from that. But apart from that, there is no deeply integrated anything into the message broker itself.
Cool. But
So
or just CloudEvents and you managed to
so
build an open telemetry out
yeah.
of your
You use the cloud event as a transport protocol, if you want to name it like that, to continue the trace on the other side. It's not really protocol, but you get it. Good. Anything else? Awesome. Thanks for your time.